it's symmetric to the origin, it's odd. Domain and range looks like to be the problem here. So we will maybe do some more of those problems as we go on tonight. Okay? Any questions? All right. Let's do our problems for 6.8 and 5.4 tonight. This is what section we are on. This is the last two sections. That we'll be covering before the test that is due this weekend. So let's talk about the first kind. There's only a few kinds. The first is slope using a graph. Now, some of you know a formula for slope, and we will use that formula slope a little bit later. But tonight's exercises, they only want you to do a graph. They want you to do it from a graph. So the first point over here is negative 2, 2, 3, 4, 5. And the second point on this graph is 3, 1. And they have a line that's drawn down through here. And the line goes through it, but those 2 points are indicated. And they want you to find the slope. Now, some of you remember from long ago that some teacher told you that it was rise over run. That's fine. But what you want to do is to try to go left to right. We do this all the time, left to right. So this would be my first point that I want to use. And then go down until you are even with the other point. So what I'm going to do is I'm going to draw some little dashed lines across here so that it kind of helps me. It kind of makes a little triangle across there. And I'm going to go from this negative 2, and I'm going to go down. It's negative 2, 5. I'm going to go down and see how far I go down until I get to this point. So I go 1, 2, 3, 4. 1, 2, 3, 4. I'm going 4 down. The direction down is negative. So that gives me a negative 4. And that's my rise. Actually, it's a fall. It's not a rise, but it's down 4. And now I'm even with this little point here. Count across then. 1, 2, 3, 4, 5. Going over, you're always going in the positive direction. But on these graphs that you're going to do tonight, all of them are going down. This is a downhill graph. This little car is going downhill. This has a negative slope. Okay, any questions on how to find that? Just go from one point to the other. Count down and over. Down is the top number. Over is the second number. Any questions on that?
Are we not counting 0 at all?
No, we didn't go down to 0.
No, when you said across.
There's 1, 2, 3, 4, 5. Don't count. You count. There's 1, 2, 3, 4, 5. 5 little spaces across here. Any other questions? Okay, let's talk about piecewise functions. That's the next one. These have parts. They're kind of fun. This one has x squared, comma, 4x is less than negative 5. 7x, 4 -5 is less than or equal to x is less than 3, and x minus 2 for x is greater than or equal to 3. It has 3 parts to it. And in each part, that's what's called piecewise. It has 3 pieces. Some of them have 2 pieces. This one has 3. For each piece, you have a region that you have to use. This is your rule part. So if they give you an x that's smaller than -5, you would use this rule. If they give you an x that's between -5 and 3, then you would use this one. And if they give you an x that's greater than or equal to 3, you would use this one. And I like to draw a picture over here because sometimes I have trouble remembering kind of where these are. So I just draw a little graph over here and say, okay, those are going to be like -6, -7, -8, and so on. And this little picture is going to be between -5 and 3, and it's going to include the -5. Remember, that's a between us form there. So this is where my values are. So I'm looking at things like -4, -3, -2, -1, 1, 2, 3. Those numbers that are in there, in that region, that's the ones that I want. And for this one, I'm looking at numbers that are greater than or equal to 3. That's like 4, 5, 6. Those are the numbers I'm looking at. So if they give me a problem and say, find f of 0, find f of 0, this is your x value you're looking for there. That's when x equals 0. That's what that means. So I figure out which one of these regions here includes the 0. It's not this one because 0 is over here. It's not this one because 0 is over here, and this one goes this way. This is the one right here that I have the 0 on. It's right there. So I come over here and I say, okay, for this one, I'm going to use 7x. That's the one that I want to use, 7x, because it's where my little 0 ended up. I'm using 7x. So I put the 0 in for x, and I have 7 times 0, which is 0. So my answer for that part is 0. Then they're going to give me another one. They're going to say, find f of -3. Well, I've got to figure out where over here my -3 is. Well, it's not going to be on that picture. It's not going to be on this picture because it's over here somewhere. It's going to be on this picture. See, it's right there, -3. So I'm going to use this rule again. We're using 7x. But this time, instead of putting in 0, I put in -3, and I get -21. Then they're going to say, okay, let's find f of -7. F of -7. Okay, well, -7 is over here on this side. See, it's this little picture. So I'm going to use this rule this time. Use x squared because that's the region that they're telling me I have to use. If I'm using -7, it's in this region. So I use that little rule right there. So I'm going to have -7 squared. -7 times -7 is +49. And they have about 4 or 5 of these. They're going to say find f of 5. Well, f of 5 is, well, this is a borderline right here. Do I want the top one or do I want the middle one with 5? Oh, it's +5. Scratch that. It's over here. 5. So I want this one. This is when x equals 5. So I'm using this rule, x minus 2. 5 minus 2 is 3. So do you see how you don't just have one little thing to plug into? You've got to first see where your x lies, in which one of these regions, and then decide which one of these little rules you want to use. Any question about that? Okay. Questions? Are y'all good?
Can you leave that up for me for a second, please?
I sure will. Let's talk about the -5 while if it had said find f of -5, let's just look at that. -5 is a border. Which one of these rules would I have used? Would I use the top one or would I use the middle one if it had said -5?
Does it matter?
The middle one.
Yes, because they're two different rules.
The middle
They
one,
are, okay.
Middle
Okay.
one. And why would I use the middle one?
because it has a bracket, so the -5 is included.
Right. It has a bracket on this one, so it includes the -5, where this one had a parenthesis, so it doesn't include the -5. So if it said -5, I would use the middle one, which is 7x. So that would be 7 times -5, which is -35. So if it's a border one, you'll have to decide which rule to use by using the bracket or the parentheses. Okay? Any questions on that? All right. You guys can't be ready for spring break, can you? Y'all don't sound like you have any questions tonight. You must be ready for spring break. All right, we're going to be given a function, and we're going to find some things. Now, they're getting ready for you to do a difference quotient here. So just kind of play along with this because you have done this before. So this should not be difficult for you to do. So just kind of go with what you know. If I'm looking for t minus 1, I'm going to put t minus 1 in the x spot. So I have 3 times t minus 1 plus t minus 1 quantity squared. All I did was put t minus 1 in the x place in my original function. So now I'm going to distribute that 3, and I have 3t minus 3. And this one I'm going to have to fool out. Now, unless you can fool this out in your head, you're going to have to write it down. T times t is t squared. And I had to do that because of this little 2 up there. It means I write that down twice. And then t times -1 is -1t. And -1 times t is -1t. And -1 times -1 is +1. So all I have to do now is clean it up. I need this t squared to be first. And then I look for t's. There's a 3t here, a 1t that's negative here, and a 1t that's negative there. So 3 minus 1 gives me a +1t. And then I have a -3 that's a number and a +1 that's a number. So that's a -2. So that is my answer to this problem. Any questions on what I did? Okay, now, if you can do that, that's really, really good. Because that's what you're going to have to do when they give you a more complicated one. If they give you f of a plus h minus f of a, and you have to do two different things. See how this is separated by this minus here? You're going to have to find two different things. Find this one first. Okay, so all I have to do, I'm still using the same little problem up here, is put a plus h in the place of x. So it's going to say 3 times a plus h, because that's where that x was, plus a plus h quantity squared. So I'm doing the same thing. 3a plus 3h, and I'm going to write this down twice and multiply it out by FOIL. So I have a 3a plus 3h plus a squared plus ah plus ah plus h squared. And then I have to just clean it up. Let's see, let's put the a squared first. And it looks like everything's all different. 3a plus 3h plus, oh, there's two of these, 2ah plus h squared. And that's the first part. This is what that is, because we put in a plus h. Okay, now then we're going to find f of a. And f of a is not quite so bad. We're just putting the a where the x is and the a where the x is there. So we have 3 times a plus a squared. That's 3a plus a squared. So I'm going to take this and I'm going to put it right there in that spot. Okay, let's see what we get here. The first one is f of a plus h, which is this long thing here. A squared plus 3a plus 3h plus 2ah plus h squared. That's my first thing, and I'm going to put it in the parentheses. My minus is in the middle. It's right there. And then I'm going to put my second thing in the parentheses. So I have f of a plus h, which is this long thing, and f of a, which is this part right here. And I need to finish it by subtracting. So I have a squared plus 3a plus 3h plus 2ah plus h squared minus 3a minus a squared. Now, if you're lucky, some things will cancel. It looks like a squareds will cancel, and it looks like 3a's will cancel. So your answer looks like 3h plus 2ah plus h squared. And you're probably saying, what in the world is the point of doing this? Well, for those of you that are going into business, you're going to do this again in business calculus. This is a calculus function. For those of you going into math or science, you're going to need to be able to do this. And you're practicing the baby steps to do this. Any questions on how I got the answer?
Okay, I know how you got the answer, but when you were drawing the arrows to the problem, that I'm a little confused on.
Okay, do you see the first thing I was finding was f of a plus h? That's because that's what this was. These are the same.
Mhm.
And that answer
Right.
ended up being this. So what I'm going to do is take this. Remember when we did those compositions and we took that out and put this in? That's what I'm doing. That's how it ended up here at the front. I'm going to take this out. I'm going to put my answer in there that I got from doing it, and I'm going to put it in the front. Then this one is what I got when I put in f of a. So I'm going to take this one out and put in 3a plus a squared. That's why it's sitting here on the end. So my original problem looked like this. I had to go through all this effort to see what it was when I put in a plus h. Now this is my answer for a plus h. So I take this out and put my answer in. This is what I got when I put in f of a. So I substitute this in for this x up here. Now then, I still have my minus that's between them. It's still there. So the only thing I have left to do is distribute that minus, and then things will start canceling. Did that help or not help?
Yes.
Okay.
I have a question.
What's your question?
When we had found the f of a plus h and we were rearranging,
Mm-hmm. Why did I do that?
we brought the a squared to the.
Why did I do that? It's just a habit to put a squared term at the front, and a comes before h. So I figured they
Right.
do the a's first, and then the h's.
Oh, all the a's first and then the h's. I just didn't know why we brought the a squared but not the h squared, since that is kind of rearranging by the squares.
There's a general rule that says when you have two variables, you try to do one of them to go down and the other one to go up. So my a's are kind of going down and my h's are coming up. So, but you could, honestly, you can put in this section of problems, you can put them any way you want to. Doesn't really matter because the a squared canceled anyway. You could have left it alone.
I didn't know that.
I'm sorry, what did you say?
I didn't know that little part about going up. So thank you.
Yeah, that's general. That I just did it automatically because I generally do that because I know that's the general rule. But you could have left this one alone because the a's are going to cancel anyway. All right, the third thing, or the third kind of thing that you're going to do that's akin to this is called the difference quotient. This is actually a derivative. If those of you that know what derivatives are, this is a derivative. This is the difference quotient. It's kind of like the quadratic formula and the formula for slope and the slope-intercept equation form. It's one of the forms that we have. It's called the difference quotient. And it's actually the first derivative of a curve. So we are going to find out these values given a particular function. So what they will give you will be f of x. They'll say f of x equals 7x minus 5. And that's great because that 7x minus 5 is going to go in that spot right there. See where that says f of x? I know that this right here is going to end up right there in my difference place. All I'm going to do is put a parentheses around it. The problem is I've got to find x plus h. And unlike the last problem where my variable changed, see, they changed to a's. So it was a little easier to put it in the problem when you're substituting a different value for x. But in the difference quotient, they leave it an x. So for some people, it's really hard to not get that confused. But what you're going to be given this. So the first thing you want to do is find f of x plus h, because if I can find it, I'm going to put it right there in that spot. This one is going to go there. What I've got to find is something to go there. So it's not too bad. All you have to do is put x plus h in for x. Okay? That's all you're doing. So in my original problem, which was f of x equals 7x plus 5, in this x spot right here, I'm going to take that out, and in that spot, I'm going to put x plus h. So now my problem is going to say 7 times x plus h plus 5, which is 7x plus 7h plus 5. So that is my f of x plus h. That's what that is. So I'm going to take this one and I'm going to bring it over here and I'm going to take this out and I'm going to put that value in its spot. There's those arrows again. Is that bothering you for me to draw those arrows there?
Does the 5 stay positive or negative?
Yeah, I think it should be negative.
Oh, it is negative. Thank you. Who was that?
I was just, okay, I was gonna say that because I'm like, where's the pot? Well, how did it turn positive?
I just made it positive. Was that Brooke?
It was me.
Man, I'm giving away the points tonight. I just hate this. Hate it, hate it, hate it. Means I'm getting old. Okay, Brooke, I gave you a point. All right.
Thank you.
7x plus 7h minus 5 is the correct response there. So now then, I'm going to rewrite this just to make it a little clearer. So in this spot, I'm going to take that out and I'm going to put 7x plus 7h minus 5. The minus goes in between there. And in this spot right here, I'm going to take this out and I'm going to put that 7x minus 5 in its spot. All over h. Now I just have to remove those parentheses. Man, I'm so glad you caught that error. I would not have gotten the right answer. I wouldn't have been able to cancel these out. I'd have been a sad cookie. See, I know these are supposed to cancel out, so if I had made that error right then, I would be going, oh, there's a mistake somewhere. These are going to cancel out. These are going to cancel out, and you'll end up with 7h over h. Then your h's are going to cancel out, so your answer for all of that work is a plain 07. That is called the difference quotient. That 7 is the first derivative of 7x minus 5. Okay.
So that second
Question?
Yes, so on the second time that you wrote it down, when you did, right before you canceled out, is it because, okay, is it 7x plus 5, like because it's being divided by something, or?
Why did it turn to a plus? Because the negative changed that 7 to a negative. The negative
Right.
changed that negative to a positive. Is that what you're asking?
Okay. Yes. Okay.
Good question. Any other questions? Okay. Let's see if we can do some of this work. Those are the kind that you'll have for tonight. Let's
I made it, Miss Sullivan.
Yes, do you have a question?
I said I made it.
Oh, is that Sequela?
It's Quay.
How are you
Yes.
doing?
I've been trying to get in forever.
Bless your heart.
It's like a shortage in my charger for my Chromebook, so it wouldn't let me in.
Well, I'm glad you made it. Did Selena ever come in? Selena or Erica Gurley or Tamala Overton or Portia's here. I thought I saw Portia. Portia's here. Kiara Thomas. Is Kiara in? Braylon Ware.
Erica Gurley's here, sorry.
Okay, Erica Gurley's here. Selena, did Selena come in? Okay, Tamala, Braylon, Chandra. Okay. All right, let's do it. Look at these problems. You're going to like the first one. This first one is really easy. In fact, I may just go from off this picture here. This is so easy. I'm not sure you're going to need to write any notes on it. This is the sections 2.5 support for college algebra section 6.8. It has a point up here and it has a point down here. And all you're doing is counting. So you're counting spaces. So don't count up here. Wait till you get to this one to count. 1, 2, 3, 4, 5. So it's 5 down. 1, 2, 3, 4. 4 over. So my slope would be negative 5/4. Do you know why it's negative?
Because he goes down.
Because you went down.
Down.
Notice I'm going left to right. So this is the first point I'm using. So I start from it and I have to go down till I get even with this other one. And then I go over. Over is always to the positive side. So let's look at this one. This point starts up here. There's another point down here. Left to right would be this one to start with. 1, 2, 3, 4, 5. 5 down. 1, 2, 3, 4. 4 over. So what's the slope of that one?
Negative 5/4.
Mhm. Okay, let's try this one. I think y'all got it. Here's one, the first point. Here's the second point. I go down till I get even with that second point. So I have 1, 2, 3, 1, 2. So what's the slope?
What's the first point? Because I really can't see that. What's the first point on that one?
This little point right here? That's
Yes.
0.02.
And what's the second one?
The second one is 2, -1.
Okay.
See how you go down 3 and count? You're counting spaces, so don't start counting here. Start with the next one down to count. 1, 2, 3. 1, 2. So it's 3 down, 2 over. Okay, now you're really going to like this because that's what you do for all the others, and they're all negative. They all go down and over. I have no idea why they decided to do this, but we're going to start introducing the slope formula here soon. This little point that's right here is the point 0,2. This little point right here is 2, -5. So what you're doing is counting down from this 2 above to 5 below. How many spaces would that be if I went from here 2 and then 5 more?
-7.
And then I'm going 2 over. So my slope is -7/2. Okay, and there's one more just like it. This is the point, looks like 6, 0, 6. It's going to come down to 2. So let's see. No, that's 7, looks like 7. So 1, 2, 3, 4, 5 down. 1, 2, 3, 4, 5, 6 across. So it's -5/6. And once you do that, you're done with that assignment. Any questions with that? It's not too bad. Those were all negative slopes.
I know that all of these are negative, but are any of them ever a positive?
Yeah, if they went the other way, they'd be positive. It just so happens that on your assignment, they didn't ask for any positive ones. They must be concentrating on you trying to figure out how to make them go downhill. That must be harder and harder concept than going uphill. But yes, any one of those that went the other way, let's just do one so you'll know what they look like. If you had one that went, oh, let's say -2, -2, and it goes to 1, 1, 2, then you could count up and over. So what we would do would be make a little dotted line going up and over, and then you count your spaces. Of course, your line's going to be, they'll have their line through there. So let's see, 1, 2, 3, 4. That would be 4 up, and 1, 2, 3 over. See that? So your slope on that positive one would be up 4 over 3. And my little, if I put a little car on here, it would be going uphill. That's because it's a positive slope. Got it? But all of yours on your assignment happen to be negative for some reason. All right, let's play with these piecewise functions. That's the next easiest thing. This is section 6.8, and this is number 1, and it says the piecewise function is defined as shown. Identify the expression that should be used for f of -6. So we have this function, x squared for x is less than -5, 7x for -5 is between x and 3. This looks like the one that we had earlier. And x minus 2 for x is greater than or equal to 3. So they want us to only find one, and they give us choices. X minus 2, 7x, and x squared. And it says, which one do you use to find f of -6? Do you use this one, or this one? So which one of those would be the area where I would find -6? Anybody know? Is it going to be the x squared, the 7x, or the x minus 2?
X minus 2.
Okay, why did you pick x minus 2? Because that's for greater than 3. And you want,
Oh, sorry. Yeah, that's right.
okay, here's the 3, and that greater than 3 would be that way.
Really, x squared.
It's this one because that's where your -6
7x.
is, isn't it? Isn't -6 this way? -6 would be right there. So it's this one you want. So you want the x squared. Okay, let's try number 2. They give you a different one. F of x equals x squared for x less than or equal to -5. No, it just is less than, sorry. Less than -5. 6x for -5 less than or equal to x less than 4. And x minus 5 for x is greater than or equal to 4. All right, now, those are the 3 areas. Which one do you use to find f of 10? And they have choices. A is x squared, B is 6x, and C is x minus 5. So which one do I want for if I was finding an x value of 10?
C.
See, 10's gonna, if I had this one and 4 is here, my 10 is going to fall in there somewhere. So you're right, it's that x minus 5 rule. Okay. All right, then they give them one more of these. This is f of x equals x minus 4, and this one's for x is less than -1. 8x for the x's that are between -1 and 2, and x squared for x is greater than or equal to 2. And they want to know which one would you use for f of -1. And again, they have choices. They have x minus 4, 8x, and x squared. Which one would you choose if you wanted -1? Now, this is a border one, so you have to be careful. You want the 8x. Why do you want the 8x?
Because it's greater than or equal to 1 and less than 2.
That's right. That less than or equal to right there includes that -1. So you want to use this rule. Okay. All right. Then they change and they give you some of your ones that you've already been doing. And this particular one has a value at -2, -2, and 2, -2. And the problem looks like this. And they don't have the ordered pairs in there. So what you need to do is go into your problem and either sketch the graph of it or just write down somewhere that this point is -2, -2, and this point is 2, -2. Because they're going to ask for you to find the areas increasing, decreasing, constant. Okay, this is number 4 in the section. Let me pick somebody. Natalie. Natalie, are you up to this today? Pick one of them.
Attempt.
Pick one of them, increasing, decreasing, or constant, and tell me what it would be. And remember, you have to use parentheses, you have to use x values, and you have to go left to right.
Okay, increasing,
Okay,
I believe, is parentheses for 2 and then positive infinity.
that's correct. Good job. And it would be this little segment right over here. That's where it's increasing. Okay, let's see. Chantel, are you available? Can you pick one of the decreasing or constant and tell me which one it is? Are you brave? Are you there? Let's see. Let me pick on somebody else. How about Lori? Lori, are you there?
Hi, yes, I'm here.
Okay, pick decreasing or constant and tell me what it would be.
I'll do constant.
Okay, what is constant?
Constant is parentheses. Or wait, is it bracket? I think it's bracket actually.
No, the 3 things you remember is use
Oh wait, I'm thinking
parentheses,
Randy, my
use
bad.
the
Okay.
x values, and go left to right.
That's -2, 2. I was thinking of the range.
Mm-hmm. Yeah, the range would be a bracket.
Range would be bracket, but yeah, thank you.
Okay. Let's see, Corey, can you do the decreasing one?
Should be parentheses, negative infinity and -2.
Mm-hmm, very good. Any questions on that? You know, if y'all, this is just a practice thing. If you do enough of them, you'll get them. All right, let's try another picture. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Negative 9, 7. And 1, 2, 3, 4. Negative 4, 7. And this is an open circle there. And negative 4, 2. Negative 2. And negative 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2, 9. Okay, goes up there. Negative 2, 9. 2, 7. 7, 2. It's a negative 2. And 8. 8, 5. Okay. Now this one they don't want the range and domain. They want intervals, increasing, decreasing, constant. Okay.
Dr. Sullivan, can you write the coordinates to that other point?
Oh, thank you. It is 2, 7. All right. Let me pick somebody. Astanika, pick increasing, decreasing, or constant, and pick one of those and tell me what the answer is.
Constant is going to be parentheses -7 to -4 with a bracket.
That's a 9.
-9. So
Negative 9 to -4, but no bracket. Remember intervals. Use only parentheses, use the x values, and go left to right. Remember intervals. You're thinking of range and domain. Okay, that's the only constant there is. Eric Walker, are you brave enough to pick decreasing or increasing?
Yeah, sure.
Okay.
First and only decrease is 2 to 7.
Yep. Notice how I used the x values and I used parentheses. Okay, increasing. Increasing's harder. Morgan, are you up to doing an increasing?
Would it be -4 to -2?
Mm-hmm.
And then 7 to 8?
Yes. Y'all are good at this. Okay, let's try one more of these. And this is on this set for section 6.8. And I know you've already done it. So hopefully this won't be bad for you. So it looks like I have a point at -6, 2. See, it's important for you to know the points to be able to do this. That's why you need to put in your, oops, sorry, that's -8. Move my point over. I'll just start all over. 1, 2, 3, 4, 5, 6, 7, 8. 8, 2. And 6, -2. 1, 2, 3, 4, 5, 6, -2. -6, -2, -8, +2. And this is one of those parabola looking things that you guys had on your homework. Some of you remember looking at those. And it goes over to -2, -2. Then it goes up to -1, 1. And then it goes across from -1, 1. And we want intervals, again, increasing, decreasing, constant. Okay, who have I not picked on tonight? Portia. Portia, can you do this? Are you there?
I just want to watch.
You just want to watch. Margaret Davis, can you do this?
Sorry, I was on the same page.
You just want to watch too, huh? Okay, Brooke, pick one.
The constant's -6, -2.
That's right. It's going straight across from -6, -2. Margaret, did you have that? Did you think that was right?
Yes, ma'am.
I thought so. Okay, Erica Gurley, pick increasing or decreasing.
It's increasing.
Okay, where's increasing?
Negative infinity to -8.
Good job. And where else?
-2 to -1.
Very good. All right, now then, constant. We did constant. Well, there's another constant in there.
To -1 to positive infinity.
A -1 to positive infinity is another constant. We have two constants on there. There's one here, and there's one here. How about downhill? Do we have any decreasing ones?
-8 to -6.
Very good. Okay. I really think that you guys can do that without any problem. All right, let's try something different. Number 7 is determine the relative max or min and the intervals. Increasing, decreasing, and there's no constant because this is a parabola. And all they give you is the picture that looks like this, and it has a little point up here that is the vertex that says 2.5, 3.25. That's what they give you. Then they have these two little things that says relative max, relative min, and you're supposed to decide which one it is. So which one is it?
A relative max.
It's at the top, so it's a relative max. Then it says the relative maximum. Now see, if you didn't know that, you could just read this sentence and it would tell you it's a maximum. Occurs at x equals blank and has a value of blank. So what would we put in this first blank?
2.5.
2.5, good. So what would we put in the second blank?
3.25.
Then it says interval increasing. Can anybody tell me what the interval increasing is?
Negative infinity to positive 2.5.
Very good. How about intervals decreasing?
2.5 to negative infinity.
You think it's negative because it's going down, but remember the x values going this way are positive x values. So that's positive infinity. This one right here is sneaky. Okay. All right, this is number 8. And in this one, we have a curve that looks like this. There's a point here and a point here on the curve, and they give you these points. This is 2, -1, and this point is 8, -19. They give you the points. And then they have these sentences you have to fill in. Relative max is blank at x equals blank. Relative min is blank at x equals blank. And they want the interval increasing and the interval decreasing. So let me pick somebody. Let's see. Shaquila, can you do any of those blanks? Are you there?
This one was kind of a little tricky for me when I was trying it out, but is the relative max positive infinity, or is it at that point of -2.1?
It's at 2, -1. So what is the x value at the max?
Okay.
What is the x?
So the x value at the max
is
2.
2. And what is the y value?
2 is x value. Mm-hmm.
So the y
-1.
value is -1, and the x value is 2. Mm-hmm. Okay, now, Sequoia, do this one. On the minimum, what is the x value?
The x value is 8. And,
that's right.
Yeah, the x value is 8 and the y -19.
Mm-hmm. That's where those goes. Very good. All right. Let's see. Amanda, can you tell me the increasing or decreasing?
Yes, ma'am. Increasing is -infinity to +2, and 8 to
+infinity. Good job. Okay, so what is decreasing? Anyone know what the decreasing area is?
The middle area, 2, 8.
Yep, that's it. Good job. All right. Now then, let's do number 9. Number 9 is very similar. It has a graph that looks like this. And it has the points on there. You don't have to find the points. It's on there. And it's the same thing. Relative max is blank at x equals blank. Relative min is blank at x equals blank. Okay, so Eric, can you do that?
All right, the relative maximum is 1 at x equals 0.
Good job.
And the relative minimum is -3 at x equals 2.
Good job. Okay, let's look at 10. 10 is a piecewise function. And you have x plus 5 if your x is less than or equal to 4. 7 minus x for the x that's greater than 4. So you only have 2 areas on this one. So they're asking us to find g of -6. So which rule do we use if we want the x value to be -6? Is it this one up here, or is it this one down here? Anybody know?
X plus 5.
It's the x plus 5, because 6, if I'm doing 4, and I want -6, which is down here somewhere, that's that region that's right there. -6 is less than that 4. So I'm going to use the x plus 5. Use x plus 5. So I put in -6 plus 5, which is -1. That is my answer. Let's try another one. Let's do g of 4. G of 4, Corey, what would you do? Are you there, Corey? How about Kiana? Are you there? How about Natalie? Did everybody leave me because this is too easy?
No, ma'am, I'm here.
Okay. So what do you think? 4. Which one would we use for 4?
I think it's that first one, x plus 5,
That's right.
because it's also equal to that symbol.
Because it has that equal to under there. So I put the 4 in for the x. 4 plus 5 is 9.
I don't know how that works.
Why? You don't know how it works?
Oh, my bad. I'm talking to myself, looking at something else.
Oh, okay.
I didn't know I had my microphone on, sorry.
Okay. G of 5. G of 5. Morgan, are you there? Which one would we use for this one?
7 minus x.
7 minus x. Now, why do we use that one?
Because you need the numbers greater than 4.
So 5 would be in that area. So I'm going to put the 5 in that x spot, so I get an answer of 2. Any questions on that work? Okay. Hopefully that'll be really easy for you guys to do. Now then, we are on this section, and I'm only going to do a couple of these because these are so redundant. If you just can do 1 or 2, you got them. This is section 5.4, and this is number 1, and here's your function. F of x equals 3x plus x squared. And they want you to find
I'm over this shit.
f of p plus 1. F of p plus 1. So don't make it hard. It's not supposed to be hard. It's supposed to be easy. So all you're going to do is take the p plus 1, and where are you going to put it?
And for x.
Put it in for x. So it's going to say 3 times p plus 1 plus p plus 1 quantity squared. Okay? So that's 3p plus 3 when I distribute the 3. And this p plus 1, you just have to write it down twice and multiply it out. There's a lot of just tedious work with this exercise, but it's not difficult to do. First, outer, inner, last is what I did on that one. So now then I have p squared, and I have 3, 4, 5p, and 3 plus 1 is 4. So there's my answer. Now the ones you might have trouble with will be this one and the other one. F of a plus h, you're going to have to find first. So f of a plus h is 3 times a plus h quantity squared.
You might have already answered this, but where does that 3 come from?
Came from right here. This is
Okay, so we're still, okay, never mind.
substituting this a plus h in that x right there, and in that x2. Okay, you got it?
Thank you, whoever asked that.
Yeah, I just thought we were on a different problem. And I just got confused. Sorry.
Oh, there's a whole bunch of these
I
that
needed
go
to know
with
that.
the same problem. They're going to ask you to find about 5 of these different things to go. And in each case, you put whatever's in this parentheses in for X, and it starts a new problem over every time you do it. But you
Okay, so I'll
basic
get,
graph.
okay, so we figured out the first part.
No,
And so
not yet.
after,
Not yet.
no, I mean the P plus 5, the
Mhm.
P squared. Okay, that's what I mean. Okay,
That's the end of that problem.
right. And so,
Now we're going to do this one. This is problem number 2 of this. We're still
okay,
using the same function. It's just problem number 2 of it. So I'm finding f of a plus h. I'm putting a plus h in the x spot up here. See, it used to say 3x plus x squared. Used to say that. Okay. So that's 3a plus 3h plus a plus h times a plus h, which is 3a plus 3h plus a squared, h squared. And that's first, outer, inner, last.
okay. I'm confused again. Okay, so I think I'm getting confused because it's like we've already done that first part up there, but the
part?
F, yes, but the F, like, what is that? What is that? Like the F times a plus h, like, that's what I'm not
It's a new
understanding.
problem. This is like just the p plus 1, except now it's changed. It's a plus h you're putting in there. So just don't think about that up there. This is like a brand new problem we're working here. And we're using the 3x plus x squared still. That's the main function. But we're putting in a plus h. It's kind of like those where we found f of a, f of 3, f of -1, f of a plus 2. Those kind of problems where we put whatever's in here in the place of the x in our function. That's what we're doing, except these are added. So it makes it a little more difficult. You're just taking this a plus h and sticking it in your x spots in your original problem. This is my original problem.
You're like substituting everything for X, if that makes sense.
That's correct.
Yeah, I
And
get
you
it, but I
have-
think because it's new, like because it's different variables, it's confusing.
Okay, I'm going to switch and just for a second and show you what these look like. See, this is a function, and for this function, you're going to find t of 1, p plus 1, a plus h minus f of a, t minus 4 plus c. See, these are 4 different problems that we're doing the same function with, and each time we're sticking whatever's in this parentheses in the x spots. So if it's p plus 1, I'm sticking p plus 1 in the x spots. If it's a plus h, I'm sticking a plus h in the x spots. If it's t minus 4, I'm sticking t minus 4 in the x spots. Whatever's in this parentheses is what I'm sticking in the x.
Okay.
Okay? And so there's like 1, 2, 3, 4 different things to do for this same function, this at 3x plus x squared. So you get one answer and then you forget it. Then you start all over and you put p plus 1 in and you get the answer. Then you forget it. And now we're at this one where we're sticking the a plus h in and we've got to get an answer. And we've also got to put the f of a in there and get an answer. And then I got to subtract the 2. This one's the hardest because it has 2 different things you're doing in the same problem. Whereas these just had a t plus 1 you stuck in there and you were done. This one has a p plus 1 you stuck in and you're done. But this one's got an A plus H and an A that you've got to stick in there. So this is like two problems within a problem.
Okay.
Okay. So those are all separate kinds of problems. All right. Now I'm in the process of sticking in the A plus H. And notice I put it in the X spots. That's why it's here. And that's why it's here. And then I had to write this down twice to square it out. So the rest of this is just algebra trying to figure out what I've got. So now I have 3a, and I can put that a squared. Somebody asked me about that earlier, and I put it in the front. The only thing I can combine is that AH. There's one here and there's one here, so that's 2 AHs plus H squared. And this whole big thing right here is my F of A plus H. That's what that is. Took me all that 4 steps to figure out what that was. Okay, now then I'm going to plug in F of A because I have this part of it I need to do. So F of A, I'm just sticking the A in that X spot this time. Okay, and it gives me 3A plus A squared. Now then I have to actually do the operation. There is a subtraction operation between this function and this function. So I have to do F of A plus H minus F of A. F of A plus H is this value right here. So I'm going to take this out and put it in this long, long thing right here. 3A plus 3H plus A squared plus 2AH plus H squared. The minus comes in between here. And now this F of A that I got here is going to go in that spot. So I'm going to take that out, and I'm going to make 3A plus A squared go in that spot. I substituted.
Okay. Yeah, I get it now.
Now, the only thing I have left to do is use this negative to change these signs and then see if anything cancels. I don't do anything with this first one because there's nothing in front of it to change its sign. But this minus will change the signs over here.
You would subtract the 3a and the a squared. And it would cancel.
That's right. 3a, a squared. So my answer to this problem is this right here. For that whole problem, this is actually the third section. I put 2 there because we didn't do the first one. We just did 2 and 3. This is actually the third problem in this set.
Can we leave it like that, or do we have to rearrange it to the h squared first?
It will take it either way in this situation. Normally, you would write your h squared first.
Okay, I wasn't sure. I don't want to like put this in and it like flags it as wrong or something.
Well, if it's wrong, then send it to me and let me look at it. This is one of those spots that's on the test that you could get this right and get this wrong, and it'll count it all wrong. And I'll go back in there and give you some partial credit for it for getting 2 out of 3 terms right.
Okay, thank you.
I don't know if any of you noticed, but on the last test and the last quiz, I went back in there and looked for things like that. So if you had 2 of the 3, terms right, but the 4th one or 3rd one was wrong, then I gave you some partial credit. Also signs, or if they decided they wanted the h squared first and they counted it wrong, and you had this answer right, I would just go in and mark it correct because that's a correct answer.
Can we do one more difference quotient? Those were kind of like confusing.
Yes, we are going to do a whole bunch of difference quotients. Let's.
Okay, thank you. 'Cause I know
Before we do a difference, what time is it?
we have like 15
Yeah, let me skip over and do, let me do this one first because this one's a little different.
Okay.
And I want to make sure that people can do this one. This is the function 3x plus x squared. It's that same function we've had all along for this problem. But this time we have this dangling c out there. Notice it doesn't say f of c, it just says plain old c. So you don't have to put the c in there and do anything with it. But you do the t minus 4. It's a f of t minus 4. That means you got to put that t minus 4 in that x spot. So let me show you how this looks. F of t minus 4 is what you're going to find. That's going to be 3 times t minus 4 plus t minus 4 quantity squared. And I'm just doing this portion of it. So I have 3t minus 12 plus t minus 4 times t minus 4, which is 3t minus 12 plus t squared minus 4t minus 4t plus 16, which is I'm going to put my t squared in the front. Let's see, 3t minus 4t, that's 8. 8 minus 3 is 5. And then I've got a negative 12 here and a positive 16 here, so that's a positive 4. So this f of t minus 4 ends up being t squared minus 5t plus 4. So I'm going to take this and I'm going to put it in that spot up there. I'm going to rewrite it so you can see where I put it. I'm going to take this out right here. And I'm going to stick that answer I got for t minus 4 in there. So it's going to say t squared minus 5t plus 4. Now I still have this plus c. It's not an f of c. It's just a plain old c. So I just added on the end to get my answer. Okay. All right, now we need to do some difference quotients. I think there's 5 or 6 of these for you to do.
Hold on one second. I'm still writing this down.
Okay,
I'm almost finished.
take your time and let me know when you're finished. I appreciate all you guys staying with me. I know this is not the easiest lesson, but you guys are doing
Okay,
well.
I'm finished.
Okay. This is the difference quotient, and you're going to have a whole set of these to do. This is set 5.4, and there's about 5 of them to do. So you need to know what the difference quotient is. It's f of x plus h. See, that's why they're having you do all that substituting in of those funny things. Minus f of x over h. So that's what we're using, and they will give us a function. They'll give us this part of it. They'll say f of x is equal to 7x plus 1. Okay, so now just think ahead. In a minute, I'm going to take this 7x plus 1, and I'm going to substitute it for f of x. See, it's the same thing. F of x is 7x plus 1, so I'm going to take this out in a minute and put this right there in that spot. But before I do that, I have got to find f of x plus h. I don't have this one. So I have f of x plus h. That means I'm going to take the x plus h and put it in the x spot right there. So it's going to say 7 times x plus h plus 1. This x plus h, I'm going to put right there. Okay, that is 7x plus 7h plus 1. And I'm going to put a circle around it because it's different from the f of x. And I'm going to put this in that spot right there. So I'm going to rewrite that just so you can see it. So in the f of x plus h spot, am I going to put the circled one or the rectangled one?
Circled.
The circled one. So I'm going to take this out and I'm going to put 7x plus 7h plus 1. Now the minus is in my problem. I'm going to leave it alone. And I'm going to take out that f of x. Which one am I going to put in for f of x?
7x plus 1.
That's right. You got it. Use a parentheses because that minus is going to change the sign on it. Notice how this little sneaky h is under there all along. Now I have 7x plus 7h plus 1 minus 7x minus 1 all over h. And then I'm hoping some things are going to cancel. 7x's will cancel, 1 will cancel, and I have 7h over h, and the h's will cancel, so I'm just left with 7.
So it's kind of like the f of g where you just substitute one and then you substitute the other one.
That's right.
But instead it's like division basically. Is that correct?
Mm-hmm.
Okay, I was overthinking this the first one we did of this, so thank you for doing another one.
Let's do a harder one. You ready to do a harder one of these?
Not really, but we'll go through it.
Let's do number 3. It's a little bit harder. It's f of x equals x squared minus 4. And you want to do the difference quotient, and they give you the difference quotient every time. They say, put this in the difference quotient, simplify, and do the answer. All right, so remember, the f of x they're going to give me. So in a minute, I'm going to take this out, and I'm going to put it over here where that f of x is. Remember that? I'm going to do that in just a minute. That's going to go in that spot. What I have to find is this part of it, x plus h. So I do f of x plus h. And what I'm going to do is take the x plus h and put it in there where that x is. X plus h, quantity squared, minus 4. So instead of saying x squared, it's going to say x plus h squared. It's the only difference. So I'm going to multiply this out because it's squared. And I get x squared plus x plus xh plus h squared minus 4. And every time I'm multiplying out, I'm doing first, outer, inner, last. Okay, let's see if that will simplify. It looks like these two can be added together. This is a plus. So I have 2xh plus h squared minus 4. Now that's my f of x plus h. And I'm going to circle it. And I'm going to put f of x plus h minus f of x over h. So which one, the circled one or the square, the rectangular one, am I going to put in here for this f of x plus h?
Circled.
The circle.
It's going to go right there. So I have x squared plus 2xh plus h squared minus 4. Minus goes down in between them. Now, what am I going to put in for f of x?
X squared minus 4.
Whoever's doing that is getting it right. So hopefully you have it straight in your brain. I hope everybody has it straight. This just takes some practice. It's not hard. It's just a matter of putting stuff in the right spot. Now remember, on your last step, something should cancel. Do we have anything that will cancel here?
X
The
squared.
and the 4.
4's will cancel. And so we have a 2xh plus h squared over h. And those h's will come out of there. And we'll have a 2x plus h over h. So my answer is 2x plus h. Now, thankfully, you don't have a lot of these time-consuming problems on the test. There's not really a shortcut to doing this. So you just have to be careful when you're multiplying out the binomial that you don't mess up somewhere. And some of them, like this one, let me show you a picture of one. And these are on your content. This is what's out there on the content. This one is a little bit longer because you're dealing with a trinomial instead of a binomial. So every time you have this x, you're putting in x plus h in that spot. So then you have to multiply it out, and then you have to combine your like terms. So it gets pretty long. But you're putting this one in for x plus h, and you're putting this first one, your original one, in for f of x, and then you simplify it down and a bunch of things will cancel. If you have an h in every spot, take out an h and then cancel that into the bottom, and whatever you have left is your answer. That's number 4. Let me show you what number 5 looks like. Number 5 is a cubic. So your f of x is 2x cubed. And when you put your x plus h in there, it's x plus h cubed, which means instead of multiplying it by itself twice, you have to multiply by itself 3 times. If I were you, I would do the last 2 first, and that gives me this. And then I simplified it down to this. And once you get this trinomial times this binomial, you take the x and multiply it by everything in your trinomial. Then take the h and multiply it by everything in the trinomial. And you get this long thing right there. But you can combine some of it. So you combine it, and then you eventually get down to this, put it in the front, put your original 2x cubed here, and then those will cancel, and you'll be able to factor out your h and get a nice little quadratic derivative. Now, do you understand that's going to take a little bit of time and effort on your part to multiply those out? And there's lots of places to make mistakes. I would have this piece of paper sitting by me when I'm doing my problem so that I can see what I'm supposed to do, and it might help you. If not, then give me a call and we'll work it out on the phone together, or I can Zoom with you or send pictures back and forth. Some of you have been doing this with me, and we send pictures back and forth to each other. So whatever it takes to get it done, we will do it. Okay. Any questions? Tonight we did slope, we did difference quotient